name is Jessica Zhao. I am a first-year PhD student at UC Berkeley in the Department of Industrial Engineering and Operations Research, where I'm fortunate to be advised by Professor Paul Grigas. I'm honored to be an ARC scholar, and I'm excited to be sharing with you all a little bit about my research. The title of my work is Scalable Data-Driven Decision-Making Under Uncertainty. First, let's talk about data-driven decision-making. As you may already know, data plays a key role in many real-world decision-making problems. A classic example is the assignment problem, where we try to assign agents to tasks, and we have data for which agents can do which tasks and the particular costs we incur when assigning some agent I to some task J. An example from the perspective of a business owner would be assigning employees to shifts, and the costs would be different employees' wages. Another decision-making problem is portfolio optimization. We have some stocks that we're interested in investing in, and we want to know how to divide our investment between them. To help us make a decision, we have some historical data on each stock's performance. Now, you'll notice that these two example problems use data slightly differently. The assignment problem is fairly well defined and intuitively easy to make an optimal decision for given its data. Before the portfolio optimization problem, even if you have historical data and choose a portfolio based on it, something unpredictable, like a stock market crash, could still happen once you make your decision. It turns out that decision-making problems often have elements of uncertainty. In the portfolio optimization problem, the uncertainty is the unknown future investment returns. If we somehow knew these future returns exactly, we could make the perfect investment decision today. But unfortunately, we don't. Instead, we typically have additional context, some data, that can help us resolve a degree of the uncertainty. For portfolio optimization, we can look at things like recent investment returns, economic indicators like unemployment statistics, and current events like international news. These can help us gauge what will happen in the future. This all leads to the question, how can we use context to help make optimal decisions? We want to ensure the expected quality of our final decisions. We also want to design algorithms that are scalable in the amount of data. That is, as we deal with more and more data, we want the computational costs in terms of time and resources to remain reasonable and not explode. It turns out that many algorithms with high decision quality are not currently scalable, and trying to fix this is the primary subject of my research. This concludes my presentation. Thank you so much for listening.